Hello and welcome to the lecture series on 8051 microcontroller. And today in this lecture we'll be discussing a sample program in assembly language in 8051. So let us take the problem statement. So the question is, we have to write a program to move the data stored in memory location from 50H to 55H to 60H to 65H. Okay, so understand the question. The question is basically uh, we have these memory locations, okay, from 50 to 55H, and at each of these memory locations we have some numbers stored here, and I have just presumed that, say, in each of these memory locations we have these datas, although I have shown it's to be same, uh, but it could be anything. Okay, so I have taken 12H in all the memory locations. The problem is to move each of these datas to the memory location pointed by 60 61 corresponding. So this data here and 52 data will come to 62 memory location, 53 data will come to 63, and so on. So these need to be populated by the value, the data 12. So let us see how we can do it in ADSM. And uh, so I have just loaded the program here, and I'll be discussing each of the instructions of this program so that it becomes quite clear, and I will be executing it in step by step so that uh, program is well understood. Okay, so we will start with the first instruction, org0h. Please remember that this is the first instruction of 8051. We have to mention what is the position of the program, okay, in the memory, in the ROM memory. So this basically points 000h. It basically points to the ROM memory location. Okay, so this has to be the first instruction of any 8051 program. So that from here to here, okay, these are 5 instructions. They have been basically used to populate the memory location 50 to 55H. Okay, so first of all we have to populate it. There should be some data in 50 to 50H, and then we would be carrying those data to the corresponding addresses from starting from 60 to 65H. Okay, so let us and that part has been done here from this instruction to this instruction. So let's discuss these 5 instructions first. So first instruction is move R0 hash 55H. I am storing the value 55 in register R0. Why I am doing it so? Basically I intend to uh, save data in memory location 55 to, I'm going basically backward here from 55 to 54 to 53, and finally I have to reach 50. So there are 6 memory locations. So in R2 I am storing 6. So R2 is basically acting as a counter, and R0 will be reduced in each step with the help of uh, DEC instruction. Okay, so let's uh, uh, move into the assembly mode of the program. So you could see here, and let me try to evaluate the program step by step. So if I press the step button, so just I will be discussing everything related to this program. So the first, after the execution of first instruction, which was move R0 hash 55H, so just see here on the left side, left window. So the number 55 has been saved in R0 register, you could see here, and moreover this R0 register is a RAM location, and its RAM location is 00H. Okay, so this is the first general purpose register of bank 0. bank 0, bank 0, bank 1, bank 2, bank 3. There are 4 banks in 8051. They are all in the RAM. Okay, the 128 byte usable RAM. So this R0 of bank 1 has a memory address of 00H. So this 55 has been saved in R0. Also see that the program counter is now pointing to 0002H. Okay, so we have started from 000H, and it has taken uh, 2 bytes while evaluating the move R0 hash 55H instruction. Why 2 byte? So let's see. This is the data memory and this is the code memory. Okay, so actually already something was written here. I haven't deleted it, but let me just focus here. So on the first 000H, 78 has been written. 78 is the mnemonic code of move R0. Move R0. So it is a uh, it is a 2 byte instruction. So uh, first byte is the opcode of move R0, and the second byte basically stores the data 55. Okay, so the next instruction has to be written on 0002, because 000 and 0001 have been storing the instruction and this data 55. So next instruction is move R2 comma hash 06H. This is counter, as I told you. If I press step, then you could see here that R2 has been saved with the number 6. Okay, and program counter has moved to 4. Why 4? Again, move is a 2 byte instruction, so it has taken 2 places, and program counter has moved to 4. So if I now it has come to this move at the rate R0 comma hash 12H. So what I am doing here, I am moving R0 to the position uh, pointed by R0. So R0 is having 55. So 12 will be saved in memory location 55. Okay. So if I press step, then at memory location 55, just see here 12 has been saved. So basically I am trying to populate first the memory location from 55 to 50 by the value 12h in all the places. So then there is a decrement instruction DEC R0. So R0 value was 55, now it becomes 54. Then DJNZ R2. So it decrements R2, which was 6, now it becomes 4. It checks whether it is 0 or not. It is not 0, so it moves to here. Here is the label, and it moves to here. So again move at the rate R0 hash 12H. So the value 12 will again be saved to the memory location pointed by R0. R0 is now having a value of 54 because of the earlier decrement instruction. So 54 will now be having a value 12 after the execution of this particular instruction. If I am pressing step, okay, so it, yes, now it has executed. So just see here 12 has been saved here. Okay, so this goes on till entire register has been populated. The memory location from 55 to 50 has been populated by 12. I'm putting a breakpoint here and I'm running the program. It will stop at this location. Okay, so I'm pressing run. So it has evaluated the set of instructions and 12 has been populated from 55 to 50 memory location. Okay, now my uh, job is to copy these values from these memory locations to these memory locations. So this should come here, this should come here, this 12 should come here, and so on. So what I have to do, again I will be using the same set of instruction, but I will be initializing 60 and 50 both of them, and I will be again using a pointer R3, which will be storing 6 because number of data are 6. Okay, and I'll be using the increment operator instruction now. Okay, so let's move step by step. So if I press step, then 60 has been stored in R1. R1 is here, so 60 has been stored there. Then I press again step. Okay, it's 50 has been saved in R0, 50 has been saved in R0 here, and then I am saving 6 in R3. R3 you see is 0 here. If I press step, then 6 has been saved in R3. Okay, then next instruction is move whatever is there in R0, whatever is there in the memory location pointed by R0. So R0 is 50, so uh, whatever there is in 50, 50 is here, it is 12, so 12 will move to A, and then I will move that value which is in A to R1, and R1 is 60. So from 50 it moves to A, and from A it moves to 60, because direct movement is not possible. Okay, it is not permissible to transfer data from one register to another register, a general purpose register. Okay, so we have to uh, uh, take two steps to do the operation. So if I press step here, okay, step it is not pressing, let me press it once more. Okay, yes, it has been pressed 2 times. Anyway, so now you could see A accumulator, this is the accumulator, it is now having value 12. Why? Because whatever was there in 50 has been copied to the accumulator. In the next instruction, whatever was there in A has been copied to the memory location pointed by R1, which is 60, so 12 has come here. Okay, then R1 will be incremented by 1, so 50 becomes 51, and R0 is incremented by uh, R naught is incremented, sorry, R1 has been incremented at 60 becomes 61, and R naught become is incremented, that means it becomes 51. Okay, so if I again press a step, okay, so R naught has also been incremented, so you see R1 has become 61 and R naught has become 51. Okay, so DJNZ R3, it will check whether the pointers are reduced to 0 or not. It hasn't, because it is 6 now. If I press it uh, and step button, and it will be evaluated. Okay, and its value will be decremented by 1, so R3 has been reduced to 5. So, and it has moved to here too. Please remember that in the same program, if we are using labels, then those labels have to be different. So I will use here as a label at this position, and here too as a label at this position. So it cannot be same. If I use here also, here and here at this position also, then it will result in an error. So this has to be kept in mind. So then this execution will go on. So I just am putting a breakpoint here. I am running the program. Okay, so and I am making the frequency as okay, it won't take much time. Let me keep it at 1 only, and I am running it. Okay, run. So you see it's being populated 12, 12, 12, 12. It is being copied. Whatever was there in 50, it has been copied to 60. Whatever was there in 51, it has been copied to 50, 61, 50, 61, and so on. And whatever was there in 55, it has been copied to 65. So hope you have understood how the program is flowing, and what each of the instructions are doing, and I hope many things have become clear in this